Okay, so here we go. We're going to talk about slope fields. And here's what you need to know about slope fields. They are literally little lines. They're called slope fields, vector fields, direction fields. And they're a way for you to graphically obtain solutions to a first-order differential equation. Now, when I say first-order differential equation, that literally means dy dx. Or dy dt, or y prime. It means it's not the second derivative, it's the first derivative. First order, first derivative. It means I can find what the graph of the original function is going to look like using a slope field. Now, we're going to create our own slope field, but before I do that, I actually want to go to this. Example number 2, you see it at the bottom of your paper, right? This is an actual slope field. It is a bunch of little slopes. Here's how you know this. The derivative, or dy dx, equals x, is the derivative for this function. Okay? Now, so if I look at this graph, and I look at 0, 1. Here is 0, 1 right there. What's the slope at 0, 1? 0. Well, that should make sense. Because when I plug in 0 here, I get out 0. What about the slope at 1, 1? How about the slope at 1, 1?
Like 1 half?
About 1 half, something like that, right? Well, and reality is, ladies and gentlemen, if you plug in 1, what do you get out? 1. So my slope here will be 1. My slope here would be 0. So, here's my question. Can you, if I put a dot at 0, 1, because it says that my initial value is 0, 1, can you draw me the shape of the original function? Keep in mind that what's going to happen is this graph is going to follow the slope fields. Well, if this is where I'm starting, is it going to look something like this?
That makes sense.
I'm following the shape of the slope fields.
Oh, yeah, because you integrate it.
Okay, we're going to talk about that in about a second. 2 seconds, yep. So I'm going to take a different color. If you've got a different color, great time to have a different color. I'm going to use 0, 0. Y of 0 equals 0. So I'm putting a dot at 0, 0. Can you draw me the shape of the graph of the original function? For 0, 0, by starting at 0, 0. Would it not just follow the shape? And what about 0, negative 3? So I'm going to put the dot at 0, negative 3. And can I graph this? Ladies and gentlemen, do you notice that all of these graphs are the exact same shape?
Yes.
They have literally just been moved up or down. Isn't that what C would do, a constant? Wouldn't a constant should graph up or down? Well, let's talk about this. I want to talk about what Isabel said for this one. Isabel, you said, what could I do about this dy dx? How can I make this? I can integrate this, couldn't I? So dy equals x dx. Yeah? So when I integrate this, y equals x squared over 2 plus c. Hey, I have a question. Doesn't this look like a parabola that's a little bit wider than a normal parabola graph?
Yeah.
Well, there's your 1/2. That's your x squared over 2. That's your 1/2 x squared. Hey, what's plus c do? Doesn't that, if x is 0, isn't that c your initial value? Oh, look, moving it up or down. There it is. So slope field, you didn't have to do this work to draw the graph. You didn't have to know anything about this to draw that graph, because I used my slope fields to draw that graph. We're now going to draw our own slope fields. That's what this is. Okay. So the first example says dy dx equals x plus y. We're going to fill in this chart. Left shape. So this chart is a way of me writing a bunch of order pairs. That's what this chart is, right? It's just a way to write a bunch of order pairs. It's just an organization tool. I'm not going to necessarily give you the chart. It would say draw slope fields for the first 9 or for the 9 points listed, and it'll just have a bunch of you. It'll have 9 dots or whatever on the graph. But I'm just giving you this. We're going to fill in this chart. So I'm going to start at the bottom left-hand corner because I can. If the x value is -2 and the y value is -2, and I plug it into my slope, into my dy dx, what are you going to get out? You plug in -2 into here for x, and -2 into here for y.
You get -4.
So my slope at -2, -2 is -4. So -2, -2 needs to be a really steep slope. Because that slope is -4. Pretty steep slope. Literally a little line.
You just kind of wing it.
Yep. Yes.
When do you ever get a vertical line?
We'll talk about this. When your slope is what?
Undefined zero.
So if your slope is undefined, then that's when you're going to draw.
Because that is infinite and undefined can go the same thing.
I have a question. For -2, -1. What are you going to get out? So at -2, -1, I should be a little bit less steep. But not too much. Right? -3 is not too much less steep. When you plug in 0, -2. Figure it out. -2. A little bit less steep. When you plug in 1 at -2, you get out -1. By the way, that means that should be at the 45-degree angle. Because -1 is -x. Literally dead smack in the middle, so that's a 45-degree angle. And when you plug in 2 and -2, you get out. Or -2 and 2, you get out. Please fill in the rest of the chart. And the rest of the slope fields. Alright. Do you have the same graph that I have? In terms of your slope fields? And I color code mine so you can see them. And again, I would not necessarily give you a chart, but I will give you a derivative, and you will have to do the derivative and then write the slope field, draw the slope field from the derivative. It's usually like 9 to 12 points that we'll usually do. A couple things that I do want to say. If you look at my dy dx equals x plus y, can you find me the original function from that? At this point in time, are you able to find me the original function from that? Why not? Because it's adding, and there's no way for me to separate it and integrate it. So keep in mind that some of these, I can't find the original function, but I can draw what the sketch would look like. That's the joy of a slope field. You may not be able to find the original function, but you can tell me what the sketch of the original function would look like. Because I have the slope field itself. Everyone okay with that? So let's talk about this. Well, we have to have an initial point. Do I have initial values? Find the solution going through. Do you have a piece of paper? Do you have a line that says find the solution going through? Alright. Do I have something that says find the solution going through? I'm actually going to do this in yellow and it's not over right. 1, 1! So I'm going to put a big old dot at 1, 1. Because I'm going to go in through 1, 1. And what do you know that this graph is doing at this point? It's doing what? It's turning, isn't it?
Sure, yeah.
It's doing something like that.
That's about right. It's going down.
This piece is coming down and that piece is going up.
Oh, yeah.
Right? What's this one? Find the solution going through. Find the solution going through -2, 0. So -2, 0. That's this one. So that would be kind of like something like this.
Yeah.
Now,
Are you supposed
obviously,
to lines or go?
no. These are two separate graphs. Keep in mind that these are two separate graphs, because think about this. Depending on where you start, won't your graph look different? Shifting-wise and everything else? That's why. These would be on basically two separate graphs. I'm just drawing on the same graph, making it easier.
No, I mean, like, do you connect, like, the slope lines?
No, do not connect the slope lines. No, these are individual little slopes. Do not connect the slope lines. These are. This is the slope at this point. This is the derivative at this point. The slope of the tangent line at 0, at 0, 1, is 1. The slope of the tangent line at 0, 0 is 0. The slope of the tangent line at 2, 0 is 2. The slope of the tangent line at -2 is -4. That's the slope of the tangent line. These are individual slopes of tangent lines. Is that better?
Yeah.
Individual slopes of tangent lines at these particular points. That's what these are. Tiny individual slopes of tangent lines. Okay? So, number 3. This is the graph of y prime equaling e to the negative y. All I'm asking you to do for this one is to sketch. And it's easiest to do, you can do this in 3 different colors. It's an FYI. You have y of 0 equaling 0, y of 0 equaling 1, and y of 0 equaling -3. These are initial conditions. Now, keep in mind, ladies and gentlemen, please check your scale. Please check your scale. And I am going to make this one. This one, this color. And I'm going to make, anybody want to do one? I'm going to make amber. Merry Christmas. You're getting one and zero to make it for easy because I've already tried.
Alright, so you pop the food, and then you go place it in the sun.
There you go. So what should she do? Help her out.
She did the purple one.
She did
Oh,
the
wait,
purple one,
she
but
did.
she needs to do what?
She goes to start it.
Alright, the red one. Mike, you're up.
Oh yeah, Mike.
Katie, you're getting the green one.
Kate, what should be?
Wait, which one is today?
Katie, you're up. Oh yeah, it's so good. Plug in 0, 2, right? Plug in 0, 2. Yeah, you can draw on that, totally. Alright! We okay with all of these? Hey, I have a question. When you integrate E, well, it's actually technically 1 over E is what you're going to be integrating, right? Because it's E to the negative y. Or, when you integrate, wouldn't it look, that's a log?
Yes.
What? Little detail was looking at the log graph.
Yeah.
Because if you're solving, think about this. This is y prime equals e to the negative y. So, you know, you'd have dy dx equaling e to the negative y. So it would be 1 over, nope, it's going to be e to the y.
Yummy.
E to the y dy equals dx. When you go to integrate this, again, keep in mind that when you integrate this, you're going to have to take it out of the exponential, put it in log in order to solve for y. That's why these are log graphs. I don't hear. I know. Logs. Right? Because this would be, for those of you like, I don't remember, e to the y equals x plus c. That's a log of absolute value of x plus c equals y. Right? Remember those? Oh look, these are all natural log graphs. We okay with that one?
Yeah.
Alright, here we go. You have matching. So, I'm going to give you a couple minutes to do it on your own, and then we're going to talk about it, and we're actually going to talk about some of these that I can separate and integrate. Alright.
How do you leave?
Focus. I'm just